Oh, each dot here is a location. I think it's a city or a province. They didn't really say location in China. And they were estimating the they're estimating the effect of certain air pollution, indoor pollutants, and there was a government policy um, north of the river. They were giving people free indoor coal. That sounds like a great idea, right? And south they weren't because it's warmer there, so you need to pay for whatever coal you want to use. And then they estimated this convenient third degree polynomial here. Not what could go wrong there. And they estimated the difference. And as you can see, if you sort of, especially if you stand right here, there's a difference of 5 years. So the effect of this policy was to reduce people's lifespan by 5 years on average. So they determined, as you can see here, I think they would have probably lived to about 98 on average if only they hadn't had that damn policy. Just hate that. It's so unfair. Um, well, this was publicized. Here it is in the New York Times. Pollution leads to drop in lifespan in northern China, research finds. I think they meant claims, but they said that. And it was published in a prestigious journal, Evidence on the Impact of Sustained Exposure. Here somewhere, life expectancies are about 5 years lower in the north. That's, north is the positive numbers, and south are the negative because it's degrees north. Yeah, north is not up there. Yeah, this is. I don't believe this for many reasons. One of which is I don't think those people were really going to be living to the age of 98, and there's really actually no reason for this curve except that the curve fits the data. Except the curve doesn't really fit the data because you see those points that there. But they followed the rules. So I would say there's a crisis in science, perhaps a crisis in scientific criticism in the sense that a few years ago, I just don't think a study like this would have been subject to this level of criticism. My own thinking has changed. I used to just accept these sorts of claims as valid, but I've seen enough of them now that it becomes clear where they're going. And there's also, I think, a growing realization that big decisions can be made based on weak evidence. So that's something that is going to concern us. Now, our job as statisticians, or my job as a statistician, is to make predictions or to learn about the population from a sample. And I'll give some examples. But first, I'd just like to say it's a pleasure to be here. I've spoken twice before here, but not in this large room, in the little room upstairs, doing workshops for math teachers. And I think I don't see much of a distinction between teaching and research. When I'm doing research, I'm trying to teach things to myself and to my colleagues. And I don't see much of a distinction between a public lecture and a research paper, which means that my research papers are written too casually and my public lectures are too technical. Uh, so what happened in 2012? In particular, what happened here? So this is public opinion in the last 2 months of the campaign. There was Barack Obama leading in the polls and Mitt Romney down here. Then there was a sudden jump down. Romney was ahead for a while, and then he remained ahead, and eventually Obama won the election. So what happened right here? What happened at the very beginning of October? Well, there was a debate, a presidential debate, in which Obama sort of looked like this, and Romney sort of looked like that. And Romney did pretty well, and if you were a Romney supporter, you thought he did pretty well, and if you're an Obama supporter, you thought Obama did pretty bad. Pundits of all political persuasions agreed. Karl Rove said Mr. Romney's bounce in the polls is significant. Nate Silver said Mr. Romney has not only improved his own standing, but also taken voters away from Mr. Obama's column. I actually pretty much disagree with these statements. But I thought this at the time. At the time, I thought Karl Rove and Nate Silver were both correct on this. But we got some data after the election. I have some colleagues who work at Microsoft Research around the corner from here, and they had done a survey on the Xbox gaming platform. So they convinced the big guys at Microsoft to put this on the Xbox. So during the month and a half before the elections, you could click on this thing and you could watch the debate, but you could also vote on the Xbox. So you could click and you got to decide who to vote for. And they got tons of data, hundreds of thousands of responses, because people are just sitting at home on the Xbox. It's non-invasive. They get to decide whether to survey. It's very easy. They got lots of data, and here's what they found. Well, it was pretty close, but then, as you see, Romney pulled ahead during the debate and never looked back, and then Romney won the election, and that's why we are where we are today. Well, they anticipate. Well, who responds to the Xbox survey? It's demographically not like the general population. It actually includes more men and more young people than the general population. That's actually not so horrible because most surveys have too many old people and too many women. So together you can maybe get a lot. But this survey alone wasn't quite right. But it's not so bad because you can adjust the survey for the demographics. Now, how do we adjust the survey? We divide the population into a bunch of categories. So there's 50 states and 2 sexes and 4 ethnic groups. And you can also categorize people by how they said they vote in the previous election. If they voted, you can characterize them by their party identification, and you divide the population to many thousands of little pieces. You estimate the proportion of voters who supported Obama and Romney in each piece, and you put them back together. And we call that multi-level regression and post-stratification. And it's not trivial to do that because in these little cells, you divide the population to little cells. In any given cell, you might have 0, 1, or 2 respondents. And so you can't really just use the raw data. You have to form a predictive model. But we can do that. Actually, that's we already knew how to do that. So we did that, and we adjusted for demographics, and this is what we found. Obama was in the lead. There's some uncertainty. The error bar is pretty narrow because we have a big sample. We have data every day. On October 3rd, there was a big jump down. Romney was ahead for a while, and then Obama won. So pretty much agrees with Karl Rove and Nate Silver. We're all in agreement. Then we did one more adjustment. In addition to adjusting for demographics, we adjusted for partisanship. And that's the new line. So let's look at that. So Obama is in the lead. Now look, the magic day, October 3rd, it just dropped a little bit. Always stayed above 50%. So this, which I believe, the adjustment for partisanship, I believe, much more than the unadjusted. Okay. Very stable. This is Obama. It's all Obama. This is a line. The different graphs were made in different ways. So this is not comparable to the earlier graph. Obama's so it's much less variable. It's much smoother, right? Like if this was a physics talk, I would say, look, we have a much better measuring instrument. Isn't this great? Okay. With the better measurement instrument, we can observe, we can detect smaller effects. Now this is supported by other survey data, Pew and YouGov and RAND surveys. How do we explain this pattern? So we call this the mythical swing voter. So there's evidence that very few voters ever change their opinion during the campaign. But big swings in the polls, sort of. Okay. We call this the dejected Democrats and the resurgent Republicans. So here, well, Obama was doing great here. Everyone thought Obama was going to win. Romney was on the ropes. Romney's getting panicky. He's looking desperate. They do surveys, and Republicans are less likely to respond to the survey. Do you want to click and play the who do you want to vote for game? No, I don't want to play that game because it's no fun to play that game. Okay, if you think your candidate's going to win, you're like, hey, the election's coming. Let's talk about who's going to win. And if you think the elections, if you think your candidate's going to lose, you're in the position of some kind of Mets fan, right? It's not going to happen. Now, then there's the big debate. And what happens after the debate? Well, then the Romney people are energized, more likely to respond. So you get this sort of ringing effect. You get this exaggeration. Now, you'd think we've talked all sorts of things. The convention bounce. You've heard about every 4 years, there are 2 presidential nominating conventions. And whoever consistently, I've looked at the data, and consistently there's between a 5 and 10% shift towards the party that had the convention. Consistently. No, and why is that? It's sort of funny. Imagine you survey someone a week before the convention. Say, who do you support for a president? Well, I support so-and-so. Next week, there's going to be a convention on TV. It's going to be a bunch of guys in funny hats getting drunk. But don't worry, you're not actually going to watch it on TV anyway, probably. And they're going to say a bunch of empty speeches. Now, who are you going to support? Well, 5 to 10% of the people should say, oh, if that's the case, I think I'm going to switch, because that's going to be really convincing to me. Hearing people say what I already know is really, well, that's sort of odd, but it's maybe not so odd that people are more likely to respond to the polls. So we learned something, all from an Xbox survey with adjustment, not a raw Xbox survey. Well, why does it work? Well, it's a big survey, so less variation. It's a panel survey, so that's key that it's the same people responding over and over. That gave us confidence that it was okay to adjust for partisanship. Because you might say, is adjusting for partisanship, is that kosher, right? Because you might say, well, from one week to the next, all of a sudden there are fewer Democrats in the sample, right? That's what I'm saying. Fewer Democrats in the sample, that's why Romney looked like he'd do better. You might say, well, maybe people decide they didn't like the Democratic Party and they switched. Well, maybe, except because we've repeated data on the same respondents, we don't see any evidence of that. So we can look at that in different ways. So it's sort of exciting, but it's also the modern way, because we're using quick and dirty data and then cleaning it up later. A lot of available data. So what we did in this project was we took the car apart and put it back together, right? But sometimes the pieces themselves are interesting. So here's a different project that I did with my colleague Yu-Sung Su a few years ago. These are, well, the data are from 2000, but forget that. Pretend this is recent. We estimated the support for school vouchers. The actual survey question was, do you support federal funding for school vouchers for paying for private schools? I don't remember the exact wording. And we estimate support for vouchers in every state by 5 income categories, from low income to high income, and among several religious ethnic groups, going from white Catholics on down. And the way we make the graph is that in each state, the dark brown colors represent strong support for federal funding for school vouchers. The blue represent opposition. Finally, when a group represents less than 1% of the population of the state, we just leave it blank. So no state, in any given state here, less than 1% of the state are rich African Americans. And so we just don't include it, because otherwise the graph would be a bit misleading, including groups that we don't have. It's not that we don't have the data for it, it's that there are so few people, it's not really the subject of our inquiry, the object of our inquiry. So let's go through this briefly. Start with white Catholics. Low-income white Catholics are pretty neutral about school vouchers, except in Illinois and Louisiana, and to some extent in New York. They like it. And you can, presumably has to do with places where there are large Catholic school systems. As you get to the rich white Catholics, you'd pretty much uniformly support vouchers. Evangelical Protestants, low-income evangelicals, tend to dislike school vouchers, but the rich ones love it. So evangelicals actually show a stronger interaction between income and support for vouchers. That's something we found in other work, that rich white evangelicals are much more conservative than poor white evangelicals, and that's larger than in other groups. Now, other whites just don't like school vouchers. Even rich white people don't like school vouchers. If they're not Catholics or evangelicals, it's just not popular. Now let's look at others. Oh, this is interesting because among minority groups, among blacks and Hispanics, the low-income ones support vouchers, but as they get richer, they become less supportive. So it goes the opposite direction. Which, well, low-income blacks in the South don't like school vouchers. Of course, private schools in the South have a very long racist history, so it makes sense that they're not going to be popular. But why is it that low-income minorities are supporting? Well, I think a lot of it has to do with the survey question, federal funding for school vouchers. So ethnic minorities are more likely to support federal funding, whereas low-income whites are more likely to not like the idea of federal funding because federal funding sounds like federal funding for minorities. So it's a complicated interaction. And we got all this by fitting the same model that we fit to the Xbox data, the same class of models. The details were different. We put many months into getting it to work. Like there are many complexities. For example, when we take the pieces apart and put them back together, we do that using census information, but you don't have census information on religion, so that has to be estimated. So there's another step in the model. There's a lot of moving parts. Now let me show you. I'm going to show you the raw data. So this is in each category the actual numbers. Well, the percentage who support. And of course, this looks like a mess because in any given cell, we have very little data. So if you stare at, now, if you look at this graph, if you look at this graph and blur your eyes a little bit, you'll sort of see this. I mean, you can even see that, like, you know, that these are going down a little and these are going up. So in some way, I think if you have access to this visualization, this is almost enough. I think of this as sort of the equivalent to drawing a line through a cloud of points. This is my best estimate. This is the raw data, which is sort of noisy. Sort of good to know this. It gives you a sense of where you might want more data. And you know, I really can't be sure about things in a lot of these states. This is just my best estimate. So a lot of the research that we do is devising graphs and comparisons which allow us to evaluate our model. Because as Andy said in the introduction, I work in Bayesian statistics, and there's a saying, I'm not sure, it's either Thomas Bayes or Pierre Laplace, Laplace was the first applied Bayesian, and I think it was Laplace who said, with great power comes great responsibility. I mean, it sounded better in the original French, I'm sure. But indeed, we have the ability to estimate all these tiny pieces and put them together, but that gives us the responsibility to check our models. And we have to make lots of graphs, and what I show you is the result of a lot of checks in different ways. So how do we do all this? Well, we use Stan. Stan is our open source computer program that fits these models. It's just very quickly, it's a computer program in C++ that allows us to express a statistical model, and then we don't have to tell it how to fit the model. It figures it out itself. We've developed a few algorithms, and we've adapted other algorithms to make it work. And we have a whole team. The thing that we're very interested in now is scalability. So as our data set becomes larger, or the number of parameters in our model becomes larger, how much more expensive is it to fit big models? This is a simple example of a model where different people are rating different items, like movies or whatever. In this case, as you have more people, as you have more data, it takes longer to run the model. But as you have more items, it doesn't really take longer. So it scales well in the number of items. If you had lots of data points, it would take forever. And so what you want to do is bend the curve and make it logarithmic. Linear is better than quadratic, but logarithmic would be better still. And that's a lot of our research right now. And our technical research is developing algorithms for this. But in some way, the research is motivated by the applied problems we're working on. OK, back to politics. You've heard about political polarization, maybe? Maybe you've heard about that. So, for example, the Iraq War, this was a few years ago. I mean, since then, I think the area in the Middle East is pretty peaceful. But back in the early 2000s, there was some sort of stuff going on, and there are big disagreements about whether we should be in the war or not. Now, you might say this is just human nature, that the Republicans support the Republicans, Democrats support the Democrats. But I don't think it's just human nature. If it is, human nature sure changed a lot in 50 years, because here's the Korean War and the Vietnam War, and we see only moderate differences. Indeed, in the Korea and in Vietnam, Democrats supported the war when the Democrats were president, Republicans when the Republican was president, but these are pretty minor divisions. Now things are different. What about domestic policy? Well, look at this. This is attitude on abortion. So higher numbers are more supporting abortion rights. These are survey respondents. Until Bill Clinton, there was no difference on average between Democrats and Republicans. As Virginia Woolf might have said, on or about 1990, everything changed, and we don't really completely understand why, but now you see big differences. Well, big differences represent big opportunities. So for example, Hispanics, a lot of Latinos have conservative attitudes on abortion. So there's sometimes this move, perhaps, that Republicans can get some Latino votes with a hardline anti-abortion stance. Maybe. But maybe we should look, before we think about what might happen if policies are changed, let's look at what's been happening so far. So I'm going to start with what I'm doing here. This graph shows pro-life and the difference between percentage who are anti-abortion of Republicans compared to Democrats. So what this says is, before 1990, there was very little difference between Republicans and Democrats in their attitudes toward abortion. But since 1990, there's been a very strong increase, and now Republicans are much more anti-abortion than Democrats. This is another visualization using a hierarchical linear model. It doesn't really matter. For the next slide, I have to use a model because our data are more sparse, because I'm going to break things up by subgroups. So I'm switching you to the model here. So this is just a restatement of what I already showed you. Abortion has become polarized, and it didn't used to be, amazingly enough. Okay, now this is just amazing to me. So here we are. Well, my colleague made the graph a couple of years ago, but I think it would be similar now as in 2004. Huge differences among whites and others, non-white, black, or Hispanics, in abortion attitudes by party ID. That is, for whites and for ethnic others, there's a large difference between Democrats and Republicans on their abortion attitudes. For blacks and Hispanics, it's essentially zero. I mean, zero. So it's not Hispanics, Latinos who are more conservative on abortion are not more likely to, at all, more likely to vote for Republicans. We have various stories as why this makes sense, but the message for today is that we can learn by slicing data into little pieces. And I'll give you another example. Oh, this is more. I don't know that you need to see that. This is similar. Now we're breaking up whites. I showed you whites compared to everybody else. Among whites, low-income whites, there's no difference between how low-income whites, Democrats, and Republicans feel about abortion. The partisan divide among abortion is entirely among higher income or higher educated whites. Just the data, make of it what you will. Now, a few years ago, I was talking to a well-known economist who was telling me that he and his family had moved away from Cambridge, Massachusetts, to a suburb of Boston because they just couldn't deal with being the only Republicans on their block. It was funny because then I looked it up, and this suburb, I looked up, I got back, I looked up this suburb, and last election they voted, it was like 65% Democrat. That's the best you could do? And he said, yeah, that was the best we could do. Best we could do. And so anyway, we were talking, and he described himself as a Jimmy Carter Republican. And I said, oh, you mean with like deregulation, and he was like standing up to the Russians, and said, no, Jimmy Carter made me a Republican, he said. And then In recent years, we've seen a lot of George W. Bush Democrats similarly. And so you can sort of see this even in the data. So this is 2008 election, just looking at Republican vote. So my former student, Yair Gitza, had access to lots of data. We have Republican vote as a function of age. And these are these George W. Bush Democrats here. And then you have maybe some Jimmy Carter Republicans. Striking patterns, really. So we're going to explore these patterns a little bit, and then we're going to fit a model. So here's the graph I already showed you. Well, we can go back. So with 2008, we have tons of poll data since 2000, easily accessible. The earlier stuff you can get, it's more work. So here I'm showing Republican vote as a function of age for each year, 2000 through 2012. I'm not giving you all the raw data because it would just be a mess. I'm giving you the smooth curves. And you sort of see something, it's not even clear. Like in 2012, 2008, young people were very Democratic supporting, but in 2000, it wasn't the case. It's hard to know what to make of this. Simple generational stories don't seem to fit. But now let's take 2012 and keep it there. 2008, move it over by 4 years. 2004, move it by 8 years. And 2000 by 12 years. So they're all lined up. We're going to line up these curves by age. And move the blue one over. Look at that. Look at that. That's just amazing. Because it's amazing because I said, try lining them up by age. And it worked. I mean, how often do things just work? Right? It just was amazing. Now, you could say, well, hey, I was making fun of those people for fitting a cubic regression, and now look at this curve. But it's a little bit different. I have a lot of data. It's clearly happening. This is, but we're going to go on from here. There's no discontinuity exactly. But so this gives us some feeling that maybe there's something to be seen. So we set up a mathematical model, and the model goes like this: that how you vote. Okay. The variation, first let me say the variation in these curves are not huge. Like it's sort of the amplitude of the variation is roughly like, on the order of 10 or 15 percentage points of the vote, right? So these are averages. So most of how you vote is not explained by your cohort. Okay. Nonetheless, these are not trivial effects. So the story is that you start and you're born, you come from some family, you live somewhere, there's some baseline political attitude. Every year you are exposed to politics, and there's a president, and the president has some popularity. And when this popularity, it's a Democratic president, you take the popularity of the president minus 50%, you multiply it by a plus or minus 1 depending on his party, his or her party, the president, and then you multiply that by a weighting factor based on your age. And what we did is, and the idea is when the weight is big, it means that politics is affecting you're malleable and you're affected by it. And when the coefficient is small, it means that it's not affecting you much and you're sort of beyond politics. And we estimated this from the data, and the only constraint in our model, we estimate a function of age, which are these weights. And the only constraint we had is that we wanted the weights to be smooth, so we put a prior on the weights, a so-called random walk prior. Basically, we constrained them to be weights for neighboring ages to be close to each other, so not allowing any big jumps. And this is what we saw. So this was pretty cool because it could have been anything, right? So it looks like the biggest effects are between the ages of 15 and 30. Now, then we have error bars, and in some sense, the confidence intervals understate the uncertainty because, they're all conditional on the model. But it's not bad to have confidence intervals of some sort because it gives you a sense don't overinterpret the squiggling around age 18. If you wanted to understand these blips, they ultimately have to do with individual data. It has to do with the fact that there was a certain year when a president was popular, and then 38 years later there was someone who didn't do so well in an election. I mean, it's ultimately just based on data, and you can't overinterpret it. Yet I felt this really helped us understand what was going on in the political generations. And you can make graphs like this. This shows the Republican vote in an average election for different cohorts. So we have the New Deal Democrats who are sort of already born 1855 to 1934, so they're already pretty stable, and things weren't affecting them that much. Then we have other groups, Eisenhower Republicans, baby boomers, Reagan conservatives, and you can see that each group, there's a period where they become volatile depending on the president that was in power. And we only did whites because minorities, there's just a whole other story. The coefficients are much smaller for ethnic minorities because they're much more likely to vote for the Democratic Party, less volatile, so you want to sort of estimate this separately. Okay. So we were able to take the data apart and reconstruct an underlying pattern. Okay. I'm going to show you another example of data decomposition now. And it started with this paper somebody sent to me. When you have the blog of the year, people just send you stuff. And they used to send me ugly graphs, and now they send me like bad research. But sometimes people send me good stuff, and so this was cool. So someone sent me this. They said, "Is this real? Influence of Valentine's Day and Halloween on birth timing." So when you see this, your first thought is, this is going to be bogus, right? And I have to say, I'm a big believer in diffusing suspense, because when you're telling a story, if you can't have suspense, then it's better just to give the answer ahead of time so people don't sort of feel like they're trying to guess. So to diffuse the suspense, I think this is real, actually. But I'm going to talk about how we look at it. But here, this paper came out, and this was their main graphs. Isn't this cute? Okay, so number of births. This was from 1968 to 1988. There's records of every birth in that period. Now, then they stopped. I think after that, the government decided to blur the records in some way. But before that, you have the date of every date of birth. And more, so they just took the mean over an 11-year period. I think we had more than 11 years. But anyway, whatever it was, over the period they had, they took the average each day. And here's Valentine's Day, and it's higher. And it's more higher for natural births and for cesarean section births. Now this seems sort of funny because you could imagine it could be higher for cesarean section births because maybe they schedule it and they're like, hey, let's schedule on Valentine's Day. That's adorable. But natural, it seems funny that natural births are just not like, because if anybody here has had a baby, you'll know that you don't have any option about when the baby's coming out. It's not like you're like, oh yeah, I'll hold it in for another day. Or like, this would be a great day to have a baby. So it's sort of funny. Well, but look, they're comparing to the other days, and so a few things that are striking. One is that it does seem, so far at least, looks like a real pattern. The second thing is this thing I told you that's also happening with the natural births, which seems odd, perhaps. The third thing is the pattern is pretty weak. They had to average 11 years of data, and you still sort of barely see it. Now, you don't have error bars on these points, but you don't really need error bars because you have 7 on each side, so you're getting internal variation. Now, here's Halloween. Isn't this clever? I've never had a graph using a symbol like that, and I really like that. And there you see you get less, and again, less natural births too, which is sort of funny. And when you see this would be very natural to say, I think there's something wrong with the data because why should it be happening with natural births too? But actually, I'll get back to that because I think it's reasonable. So when I saw this, I wrote on the blog, I said, what I'd really like to see is a graph of all 366 days. I want to put Valentine's and Halloween in context. And then while you're at it, you can also do days of the week, because we've all heard about the whole weekend thing. And also Thanksgiving and Easter, holidays that have specific dates. And because I just think it's frustrating when people only show part of the story. I mean, obviously, they had all the data, so why are they only showing 30 days out of 366? It bugs me. Okay. So people did this for me because I asked. So someone made this. You have a very high resolution projector here, although it won't really help if you're sitting in the back. I'll make you feel better by saying you don't need to focus on this particular graph. But someone made this graph of the raw data, and you can see here's New Year's, here's July 4th, and you can see here's Halloween, and well, here's Valentine's Day and Halloween. So it is pretty noisy by day. Somebody else made this graph, which was pretty, but I hate it. So which birth dates are most common? Now the trouble with this graph is really what you see as well. There aren't that many people born in January and there are a lot in August. That's interesting, but that's not the point of this study. So it is true that lots of people are born in August and September, and lots of people are actually making babies around Christmas time. That's true, a true fact. You also get to compare the 23rd of every month, which is like the least important thing. It's like getting a poll. It's like looking at all the people whose social security numbers end in 2 or something like that. And you get to find that there was no February 31st. So I hate this. Then my colleague Aki did this. He did a decomposition. This is slightly misleading because all the graphs are on the same scale, but they're all different scales, actually. So this is years. So he decomposed the data into, first, a slow trend. That's the blue line. So people are having more babies than they were back then. I mean, it's a larger population. Then he has a green curve, which is a fast non-periodic component, which is variation that's too slow, too low frequency to be at the day-to-day level, but it's not captured by years. So there are just various months, and there are various periods that people have more babies, and other periods when people have fewer. I don't know exactly why, but things are happening. People have babies for different reasons. It's not surprising that it varies, that the rates vary a little bit. Day of the week. So let's look at this. Fewer people are having babies on the weekend. Well, that's well known that the doctor won't schedule your birth on the weekend unless, if it's scheduled, they wouldn't do that. Also, he fit this coefficient to vary by time, and you can see if you look carefully, 1972 is in blue, and then you go to 88, which is in purple. So the difference between Monday and Sunday, weekends and weekdays, is greater in more recent years, which makes sense, right? They're more scheduled births, so things are less natural, right? Naturally, there shouldn't be any variation. Now, then he also fit month of year effects, and actually those have gone up too. So the difference between the relative frequency of births in January compared to September has actually changed over the years. And again, lots of stories about that. Finally, what's left are the days of the year. So here it is. They're not having babies on New Year. Valentine's Day really does stand out. Here's Leap Day. Memorial Day is it's spread out, right, over a week. Independence Day is always July 4th. Labor Day is spread out. Thanksgiving is spread out. Here's Christmas. So we fit a statistical model to decompose this. Oh, by the way, so why are natural births more common than Valentine's Day too? Because there is some decision of whether to induce or not. So it actually also makes sense. So if there's going to be a change in the number of induced births, there's also going to be a change in the number of natural births because people get to decide whether to induce or not. So it's actually sort of logical that maybe it's February 15th and they still haven't had the damn baby and they induce it. So that you could get that kind of effect. Where am I? Okay. So there's a saying in math, and I don't know the exact quote, and I don't know the exact saying, so maybe someone can tell me later, but it's something like this. When you're stuck, make the problem harder, right? Generalize a problem. So if you want to sum an infinite series, make it into a generating function and work out the generating function. I think there's a famous math quote along that lines. And it's sort of true in statistics too. Well, of course this is a lot of work, but once I do this, I've answered the question in a way that you just cannot get. It doesn't matter how hard you analyze these data, right? So I can get a better, even if all I cared about were Halloween and Valentine's Day, maybe that would be a better world if that's all I cared about. It would still be better to do all of this analysis, to attack the harder problem also. Okay? So we learn more about 2 questions by looking at 366 questions. And now let's look at what? Oh, what happened to Halloween? It's here, November. Halloween is here. Well, you can't, yeah, it's right before November. It's just that Aki didn't put it on the graph because Thanksgiving had a bigger effect. No, I mean, yeah, there it is. Not as big as Leap. See, Leap Day, I don't know about you, but like if I had a chance to have a kid on Leap Day, I would leap at the chance. but like a lot of people, I guess, think it's sort of weird, or the kid's not going to have a birthday. I think it's cool. This indicates that I'm not normal. Okay, so what happens when people study only one question at a time? Oh, also I should say, this theme about looking at many questions at once, that fits everything we've done so far. The abortion analysis, the pre-election polling, all those things, what I'm doing is asking many questions. But when you only study one question at a time, bad things can happen to you. Bad things. Like this. This was published leading journal. Women are 3 times more likely to wear red or pink at peak fertility. And it was statistically significant. That was pretty striking. Implausible, in fact. So striking as to be counterintuitive. Just because it's counterintuitive, it doesn't make it true. In fact, false. It's not at all reasonable statement. But this is what they found in their sample. Some other people did a study, the fluctuating female vote, and they found that women in committed relationships were 20 percentage points more likely to vote for Mitt Romney when they were in their most fertile period of their menstrual cycle. Because he appeals to sort of committed kind of women. But single women were 20 percentage points more likely to support Obama because he's more of their kind of guy. Well, it's actually sort of funny because it's funny that they said women in committed relationships. They didn't say married or unmarried, but of course that's because the data comparison they did was the committed relationships. I think they probably got a stronger comparison there. Now, this study, they didn't do anything about women who are in committed relationships or not, but that's because the pattern appeared just fine for everybody, so they didn't need to break it up. But they tried to replicate it later, and they found it didn't replicate, but the weather had changed, and so they realized there's an interaction with the temperature. But in this thing, they didn't actually check the weather on that. Okay, so what's going on in these sorts of studies? Okay, these are weird findings. They make no sense. I mean, I know this makes no sense because I've studied public opinion, and there's no way that there's a 20% swing in anything. It's unreasonable. Their findings are weird, and I would almost say they make no sense, but they make complete sense. If you look at a little bit of data, you can find big effects. So it makes a lot of sense. But it wouldn't make sense if applied to the general population. Yet they got a lot of press, and they got published in leading journals. They followed the rules, is what they did, which makes me wonder whether maybe there's something wrong with the rules. Now, these findings had lots of controversy. I wrote papers criticizing this, and then people criticized me for criticizing them. Then I criticized people for criticizing me for criticizing them. And there was lots of controversy. But one way to think about this is, why should we believe that asking two survey questions to 24 college students and 100 people off the internet should reveal underlying truths about human nature? Well, you're all on my side. And so it's like, but you should be on my side on this one because I'm right here. The point is that it's a funny thing because statistics is sort of does some damage here, right? Because I think as statistics is used as a way to launder uncertainty. And I think that statisticians have somehow, we've in some ways sold our field to scientists as we are these great bankers of data. And we will launder your uncertainty. All you have to do is pay us a little bit to teach courses and stuff like that. And we will take your data that's very variable, and we'll come out with averages that are very stable and believable. We'll take a whole bunch of data points, and we'll divide it into little slices. And these will be AAA slices, or I should say p less than 0.01 slices of data. And everyone will be very happy about that. And sometimes it works, like in Las Vegas, you really can have independent gambling outcomes and they can make money, but it doesn't really work in a situation like this. There are too many ways of selecting the data. It's a little bit as if someone went to Vegas and played a gambling game, but then they got to decide what was the rule for winning. So all of a sudden you play roulette and you get to pick your number afterwards, and it won't work so well. Here's another example. This is a famous example. It's the social priming study. So people were, some 60 college students were in the lab, and some of them were given neutral stimuli, and some of them were given some stimuli with words such as Florida and bingo that elicited images of elderly people. This was done sort of implicitly. You know, lots of things were going on, and they somehow mentioned that you're going to Florida and playing bingo. And then bingo, they got an effect here. Elderly people took, so people who were, these were students who were primed with words like Florida and bingo were taking longer to walk down the hall. And this difference was statistically significant. A huge literature came from this. Now, you can laugh all you want, but this guy, who was probably the guy they asked to speak and he wasn't available, so they got me instead. When I describe priming studies to audiences, the reaction is often disbelief. Here you are disbelieving. The idea you should focus on, however, is that disbelief is not an option. The results are not made up, nor are they statistical flukes. You have no choice but to accept that the major conclusions of these studies are true. No choice. And remember, this is the person who couldn't come. They invited him, and he wouldn't make it. And if he had come, you'd be standing in the hallway because the seats would all be taken. Okay, so this is what's happening. Okay, well, this is an important enough study that people decided to replicate it. And there's this thing called Psych File Drawer, which is an archive of replication attempts made from fonts from the 1970s here. And they replicated it, and let's see what happened. Well, that confidence intervals don't overlap. Look at, well, let's not, and they overlap a little bit, but let's not be, well, shoot. The people who are primed with elderly words actually walk faster. Well, it's not statistically significant, so we don't have to take it too seriously. Okay, so here was the Kahneman quote, and then more recently, some Dutch psychologists wrote about this, and they wrote, after a long series, disbelief does in fact remain an option. But Kahneman is in good company. Here was Alan Turing, founder of computer science in 1950. I assume that the reader is familiar with the idea of extrasensory perception, blah, blah, blah. These disturbing phenomena seem to deny all our usual scientific ideas, how we should like to discredit them. Unfortunately, the statistical evidence, at least for telepathy, is overwhelming. Now, what's amazing is even the people who believe in ESP now don't think the evidence as of 1950 was overwhelming. Okay, so now I want to sort of say a couple things here. And first, as I said, that I feel like we as statisticians in some sense have failed, or perhaps we've succeeded too well. And if you look at statistics textbooks, including mine in many places, you just see example where there's like a data set, a question, a confidence interval that excludes 0, you know, a p-value, a success. It's like that. Bam, 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 success. Or sometimes it's not statistically significant, and that's a success because, hey, we didn't accidentally say something was statistically significant. There's a whole theory based on type 1 and type 2 errors, which is all about the idea that there's this true effects and false effects, and you're trying to find things, and it doesn't really work. Now, on the other hand, consider our successes. So examples like the birthday study, the abortion, the voting, all these things, we are able to learn a lot. So it's like we can do so much, and yet somehow our public face is something completely different. Now, let me say this is no slam on Kahneman and Turing. I mean, they've made great contributions, obviously, to science. I mean, what's interesting is that they're brilliant people and yet overstated the strength of evidence. And also, I'm not criticizing Kahneman and Turing for believing in ESP and for believing in social priming. I mean, they both could be real. Kahneman certainly has a much better understanding of psychology than I am. What I'm faulting them is for their insistence that the evidence is overwhelming and that the rest of us have no choice but to accept the hypothesis. So great as they are, they overstated the strength of the evidence. Now, what sort of goes on every day? Well, every week, my sister is a psychologist, so she gets this thing every week, and what's been happening in psychology. What happened that week in psychological science when she emailed me this? Turning body and self inside out, visualized heartbeats alter bodily self-consciousness and tactile perception. Aging 5 years in 5 minutes, the effect of taking a memory test at an older adult's subjective age. The double-edged sword of grandiose narcissism, implications for successful and unsuccessful leadership among US presidents. The nature of intelligence, okay, this one's sort of an old-fashioned thing, we can skip that. Beauty at the ballot box, disease threats predict preferences for physically attractive leaders. Shaping attention with reward, effects of reward on so so the point is that this is central to modern psychology. Okay, this is what they do. I have a quick summary of these studies. Okay, well, not that you can't learn from 17 people. You can learn from one person, but yet I'm suspicious of statistical evidence of this sort. Again, if we go to a pre-statistical era, of course you wouldn't even believe that someone could learn from like 42 people, that like you're going to have an enduring claim about human nature. Maybe it is possible in some settings, but like I feel like the burden is on the person who's making that claim. And of course, a couple of the studies were based on some archival data. Um, Now, this is not just about joke studies, silly science, goofy, world's least competent criminals, that kind of thing. Also real world effects. So here's an example. This is a preprint that got a lot of publicity last year, labor market returns to early childhood stimulation. This was an experiment that they indeed started over 20 years ago. They went to a school or some schools in Jamaica and randomly divided up the kids, and some kids got special interventions with their families. It was a small number. I can't remember. Maybe it was 100-ish or 200, maybe 100. Here it is. The average earnings of participants increased by 42%. Now, I'm a social scientist, but not all of you are, so I don't know if you know about this. Earnings is economics jargon. It's a sort of quaint economics jargon for how much money you make. They call it earnings. It's sort of cute. So anyway, that's the bottom line for them, and their people are making 42%. So I wrote something about it in some online, now defunct online magazine. Overall, I have no reason to doubt the direction, namely psychological stimulation should be good, but I'm skeptical of the claim that differ by 42% due to reasons, okay. Lots of hypothesizing. There's nothing wrong with speculation, but at some point you're chasing noise and picking winners. So I sent this to the people who wrote the article. They didn't respond to me. But I will say a year later, the paper came out, Labor Market Returns to Early Childhood Intervention. If you go down, increased earnings by 25%. But now I feel like, I don't know if I believe, if they had just published that, I'd be like, well, I don't really believe that 25%. So it's like they can't win, right? It's like, that game you play with your class where you say, every kid in the class is going to give a number between 1 and 100. And your goal, you win if you're closest to the average of every other kid's guess divided by 2. So then you're like, well, if everyone's between 0 and 100, then 50 is the average, so I should guess 25. But if everyone's guessing 25, I guess I should guess 12. But if everyone's guessing 12, I guess I should guess 6. So then you have this race to the bottom, and everyone's guessing 1. So nobody wins. So it's like this. Well, they say 25. I don't believe this 25. Maybe 12 and a half. I don't know what to think. I don't know. This is not easy. Okay, these are hard problems. So people have thought about this. The social critic Charles Murray wrote, to me, the experiences of early childhood intervention follow the familiar discouraging patterns. Small-scale experimental efforts show effects. When they're subject to well-designed large-scale replications, they attenuate and often evaporate. James Heckman, who was involved in this study in Jamaica, said the effects reported to survive batteries of rigorous testing procedures. But it's just one data set, so it doesn't matter how many batteries you throw at it, really. They're plug into it, I guess. They are conducted by independent analysts who did not perform or design the original experiments. The fact that samples are small works against finding any effects for the programs, much less the statistically significant and substantial effects that have been found. But forgive me for saying this, but he's not being very Bayesian here, because the noisier your estimate is, if you find something, the more likely is noise. So it's actually not true. Like when he says, when the samples are small and it works against finding any effects for the programs, if you do find an effect, that's actually, it doesn't mean like, hey, I survived. It means like, hey, maybe I got lucky. That's how you have to think about it. Now, I'm not saying that Charles Murray knows about this stuff, and there could be large effects, but I do worry, and it's a challenge, right? So remember, my general approach was going to be that we attack the larger problems, so we look at more things. Well, we could do that with observational data. With an experiment, you can't really do that. I guess the answer for experimentation would be to do lots of experiments and analyze them in a coherent way rather than one at a time. If you think about medical research, that's how medical research and a lot of education research is. Lots of people are doing experiments, But the idea is it's like craft work. Each group is analyzing their own experiment. They get lucky and they publish, or they don't get lucky and they don't publish. Then later, actually, I shouldn't say they don't get lucky. If they don't publish, they're just not good enough at finding something from their data. So, but then eventually, then people do meta-analysis, and it's sort of a mess. So ideally, there'd be more coordination, and there is a move to that. I'm not the only one saying that. Okay, so let me conclude with this sort of soothing thought. I think there's a lot to this. If you, yes, let us have the serenity to embrace the variation that we cannot reduce, the courage to reduce the variation we cannot embrace, and the wisdom to distinguish one from the other.